Do some practice exercises from section 5.1 here. So let's do number 3. You have express checkout line and a super express checkout line. So x1 is the express, super express is x2, and x1 is the number in the express checkout, and x2 is super checkout. So what's the probability of x equals 1 and y equals 1? That's just the probability of 1, 1. Or 0.15. B asks, what is P of x1, x2? That is the probability that the numbers in the customer two lines are identical. Well, so we need 0, 0, 1, 1, 2, 2, and 3, 3. So P0, 0 plus P1, 1 plus P2, 2 plus P3, 3. And that's equal to 0.08 plus 0.15 plus 0.10 plus 0.07, and if we add those all up, we get 0.40. Let's look at C. Let A denote the event that there are at least 2 more customers in one line than the other line. Express A in terms of x1 and a2 and calculate the probability. Well, what that means is that A will be the event that, let's see, so x1 is going to have 2 more than x2. Union x2 is going to have 2 more than x1. So the probability of A is we're going to have to figure out the different ones. So if 2 is going to be greater than x2, we'd have 2, 0 plus 3, 0 plus 4, 0 plus probability of 3, 1, not 3, 2, but we would have probability of 4, 1 plus the probability of 4, 2. Plus, let's go the other way, plus the probability of 0, 2 plus the probability of 0, 3 plus the probability of 1, 3. And I think if we add those all up, 0.05, 0.4, 0.9, 14 that way, and then 0.2 would be 21. No, here, plus these 3, and I think what you end up getting is 0.22. All right, let's try the next page. What's the probability that the total number of customers in the line is exactly 4, and then at least 4? So for D, then, the probability that x1 plus x2 is actually equal to 4. Well, let's see, we could have 4, 0 plus probability of 1, 3 plus the probability of 3, 1 plus the probability of 2, 2. I think that's all of our possibilities, and I think if you add those all up, you get 1, 7. It's actually kind of going up this line, 3, 13, 17. Yeah. So let's find the probability that x1 plus x2 is greater than or equal to 4. Well, that's the probability of x1 plus x2 equal to 4 plus, so let's see, I guess we go down this soft diagonal. So we would add in all of these on this subdiagonal plus everything below it. So let's see, 0.01 plus 0.05 plus 0.06 here, 4, 1, 4, 2, 4, 3, and then 0.04 plus 0.07, 3, 2, 3, 3, and then 2, 3. I think if you add all those up, you end up getting 0.46. Okay, so that's how you do at number 3, but number 4 continues this on. Determine the marginal probability of x1 and then calculate the expected number of customers aligned at the expected checkout. All right, so x1 is here. So what we want to do is keep x1 fixed and add those across. So x1 and then the probability of x1 of x. So if we have 0, we keep x1 fixed and add all these across. P of 0, 0, P of 0, 1, P of 0, 2. And so let's see, 8, 15, 19. That would be 0.19. 1, keep 1 fixed and add them across. 21, 30. And then across here, 9, 19, 25. And then 3, 7, 14. And then finally for 4, we get 0.12. And so these all should add up to 1. Now it asks for us to find what the expected value would be. So the expected value of x1 would be 0 times 0.19 plus 1 times 0.3 plus 2 times 0.25 plus 3 times 0.14 plus 4 times 0.12, and if we calculate that expected value of that marginal probability, let's see, 0.3 plus 0.5 plus 0.42 plus 0.48, 80, 98 if I did my calculations correct, and there's no guarantee for that percent. Part 2, determine the marginal PDF of x2. So again, x2 would have 0, 1, 2, and 3. We keep x2 fixed and add up these numbers, 14, 19. x2 is 1, 22, 26, 29, 30. 19, 23, 28. And then 10, 23. And that looks to add up to 1. And then finally it asks in the question, by inspection, the probability of x1 equals 4, x2 equals 0, and x1, 4, 0, are they independent random variables? Well, so let's kind of check that out. P of 4, 0 equals to 0, but P1 of 4, which is up here, is 0.12, and P2 of 0, which is there, is 0.19. But those are not equal. 0 does not equal 0.12 times 0.19, so they're not independent. The express and super express do depend on each other. All right. Let's take a look at number 10, that Annie and Alvy agree to meet between 5 p.m. and 6 p.m. for dinner at a local health restaurant. Let X be Annie's arrival time and Alvy's arrival time be Y. And they're independent, which each uniform distributed on the interval 5, 6. Okay, so if it's 5, 6, we could draw it with X, and X is Annie, and Y is Alvy. And we could go between 5 and 6, 5 and 6. So we have this little square right here. And since it's uniform, P of xy, or f of xy, must be equal to 1 times 1, or 1, since both of those have a height of 1. So that's the joint PDF of that one. And there are a lot of problems like this where you have the uniform distribution and you're adding them together. So we should probably say this a little bit better, that f of xy equals 1 if x is between 5 and 6, y is between 5 and 6, and 0 elsewhere. Points off for style points because I messed that up like that. Now let's go to the next question. What's the probability that they both arrive between 5:15 and 5:45? Well, okay, so let's kind of draw that in here. Let's zoom in to 5 and 6, 5 and 6. So here's at 5:15 and 5:45, which would be 5.25 and 5.75, and then Alvey also comes in at 5.2.5 and 5.75. So you could figure this out by independence, because these two are independent. You could take 0.5 times 0.5, and so there's a probability of 0.25 that they both arrive within 5:15 and 5:75. That's one way you could do it. The other way is just notice that this area of the rectangle or the square is 0.5 times 0.5, and then you multiply by 1, then you get 0.25. That's another way you could do it. Or you could integrate, in which case you'd still get the area of the square times 1. Now, if this had been other length other than 5 or 6, you would have to multiply by the height. But in this case, the height was just 1. So we don't have to worry with that. But you may have problems where that does happen. All right. Let's look at part C. If the first one to arrive will wait only 10 minutes before leaving to eat somewhere else, what is the probability that they have dinner at the health food restaurant? Okay, so they'll leave this health food restaurant if they have to wait for more than 10 minutes. Well, 10 minutes is 1/6 of an hour. So let's kind of think about that. Here we have our square. And so, like, the one has to happen within 10 minutes or 10 minutes earlier than the other. So this equation is y equals x minus 1/6. This is y equals x plus 1/6. So if they were in the middle, they arrived at the same time. Let's suppose one arrived at 5:30. Then the other person would have to arrive either at 5:20 or at 5:40. So add 10 minutes to the side. The same thing here. You add 10 minutes to both of these sides. Now when you get to this part, if you come too early at 5 o'clock, they're not going to arrive earlier than 5:05, so you have to take that into account. So again, if you arrive at a particular time, you have 10 minutes before each of the other time for the other person to arrive. And so that's why you've got this band. So if you think about it, that this probability that they will eat at the health food restaurant is this sum right here. This is at the health food restaurant. But these down here are not. Now, the one thing you can think about this of doing is, well, let's figure out just the area of a triangle. We don't always have to integrate to do this. Let's call this H for health food restaurant. So the probability that they want is that xy is an H is going to be equal to the integral of h of 1 dx dy. But that's the same thing as the area of h. But that's also the same thing of 1 minus the area of h prime. And if we think about this, we have nice triangles here, so we can figure out base times height 1/2. So this length of this triangle is 5/6, the height is 5/6, 5/6, 5/6, 5/6. So I can have 1 minus 1/2 5/6, 5/6, minus 1/2 5/6, 5/6, and that will end up giving me 1 minus, 25 over 36, a half, minus 1/2, 25 over 36. So that'll give me 11/36, or about my calculator, about 30.6%. Okay. So this area right here was that absolute value of x minus y is less than 36. Just one more thing, just to kind of see the ideas that these conditional probabilities here at this part down here. Let's just kind of take a look at this one at number 3. Here we go. We've got these probabilities here. Let's suppose that I want to find f of y given x, and let's just say 1 given 2. So this right here is x equals 2, this is y equals 1. So this would be p of 1, 2 over the probability of x equals 2. Well, x equals 2 is 0.25. Probability of 1, 2 is 0.05, and that would then be 0.20. So again, it's just a reminder of how you calculate these f of y given x. Let's go the other way. Let's suppose we had f of x given y of 1, 2. In this case, we have y equals 2. And this one we have x equals 1. This would be the probability of 1, 2 again, but this time it's the probability of y equal to 2. And so the y equals 2, I think that's a 0.28, and the numerator is 0.05, so 5/28 would be that conditional probability. All right. Hope this helps. Hope you can do well on your homework, and may God's blessings be upon you.